How often do you get random photos, and how do you get rid of them? So maybe like 6 times a day. Hello, this is a live study with me. I thought I'd come early and not tell anyone because last time the quality is so bad. Last time people turned up and I got distracted and started talking. So I think I'm going to drop this down. This is on my textbook holder. I'm genuinely studying. Ignore my room. I'm organizing. I've got all my textbooks on the floor. I mentioned I have like 30 language textbooks. So yeah, and my chair makes weird noises, but we move. Let me set a timer and start studying. Make it right, make it right. Ooh, make it right, make it right. Ooh. Okay. I don't say too much. She won't marry me, oh, but she's happy with you. My life is sweet, but it's sweet too. Your body knock you low. Someone sent me homework. Who is it? Why would you do that? Required practical 6, objective test. Okay, sure. Gonna girl, let's say she won't marry me, oh, but she's happy making and your love is sweet. Your body knock you low. That's actually everything I'm going to need. She won't marry me, oh, but she's happy making. Resources. Whoa, what happened? I thought I was live streaming. Okay, I am live streaming. Phew, I got a bit confused. Hi, Amma. Hi, Shrubtill. Hey, Tay. I'm gonna call you after this, Tay. Don't worry. So we can catch up. Do you know ASMR? Can you try tapping your fingers on the table close to the camera sometimes? Okay. I'm not wearing my fake nails. When I'm wearing my fake nails, it sounds better, I guess. I don't know where the microphone is on this because it's a new laptop. Since my last study with me, I have gotten a new device because our school gives them to us. And my old one was really slow and it just wasn't doing it for me. So I got a new one and quality tapping. Thank you. We actually need to do a live stream study with me together, Tay. That needs to happen. This hairband is so flimsy. Thank you. That's okay. What was I saying? I don't even remember. Yeah, so I got the new device and what am I doing? I'm pretty sure I've already printed this off. Let me go and check. Today we are making my maths chemistry. I'm going to start off with atomic structure. That's such an ugly R. But it is what it is. It is what it is. I'm thinking 8 a.m. every day. 1 hour live study with me. It will mostly be maths, to be honest, but I mostly do maths first thing in the morning because that's when I have the mental capacity to do so. If it's after 12 p.m., I can't do maths. 12 p.m., 12 a.m., 12 p.m. Let me actually see if I've printed this off already. That would be useful. She won't marry me. Oh, that she's having oh. Oh, heavy. Oh, that she's having ah. What's going on? Right, I have the whole spec here, then I have this spec for just this section. Oof. Okay. If you can do it every now and then, it would be great. It's really like, got it. Okay. Sweet. Ouch. Hair, atomic structure. Tough. Who do I actually need to know about? History of the atom. Bonding. Okay. It's evolved over time, but you're not being specific because you're really not telling me what you want me to know. So there was obviously JJ Thompson. History of the atom. Story. We had the Greeks, and then that went to oh, that's a good timeline actually. From the Greeks, we went to honey, work please. Yeah, so that was Democritus. Then we had Dalton. And then we had JJ Thompson. And then we had Rutherford, Bohr, and then today. Rutherford, Bohr. So that was that. There was the sun, the sea, whatever. That was the solid sphere. That was the plum pudding. What did Rutherford? He was the gold film guy. He's gold film. What did Bohr actually do? Is Bohr the one? What did Bohr find? I think he found the nucleus. Bohr model of the atom. Why is my head hurting so much? Right, come on. This is a touchscreen, by the way. I'm sure it looks weird that my hands are moving towards you. Electrons, orbit, nucleus. Who discovered the... Hold up. Because I've written this down before. Who discovered the neutron? How did you know Google? Chadwick. When was Chadwick? Neutron was Chadwick. How did I forget about Chadwick? Electron was definitely Rutherford. No, electron was Thompson. I did a presentation on this. Wow. So J.J. Thompson said electron. Rutherford said positive charge, maybe. What did Rutherford actually say? Yeah, so Rutherford was the proton. Thompson was the electron. Do I actually need to know about Bohr? And then there was Chadwick at some point, but when was Bohr and when was Chadwick? Is Chadwick that important? Who discovered the neutron? What year was this? This is in 32. When did Bohr do his stuff? Bohr model. Okay, so Chadwick came after. I thought so. Chadwick, because that's not even 100 years ago. Okay. Can you explain how knowledge of atomic structure has evolved over time? Yes. Can you describe how protons, neutrons, electrons have relative charge and relative mass? I can explain that. Relative charge. Can I spell? Charge and mass of subatomic particles. Let me. There we go. That looks cuter. Okay. Subatomic particle. Mass. Charge. So we're going to have proton, neutron, electron. Mass is 1 over 1842, maybe? 1842, yeah. And then charge is +1, 0, -1. Gorgeous. Can you describe the nucleus? Boom, 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 boom. The nucleus, okay. Nucleus equals protons and neutrons. A is mass number. Z is atomic number. Z is atomic number. Plum pudding model is Thompson. Thank you. Hi, Yummy. Isotopes. Isotopes have different number of neutrons. Can you explain time of flight spectroscopy? Yes, because we've done it so many times, but let me just double check. I think I'll put it at the bottom of my page because it's quite a large topic. Time of flight mass spectroscopy. Oscopy. I don't know. Mass spectrometry. Oh, I learned it wrong. Spectrometry. Okay. 0, 1, or 2, 6, 5, 6. This records the time it takes for ions to reach a certain detector. It makes a spectra to depict ions that are present. Ionization, acceleration, ion drift, detection, and analysis. Ionization can be done with an electron gun, or it can be done with a hypodermic needle, which is called electrospray ionization. It's all coming back to me. There we go. Ionization, I can spell. Either electrospray with a hypodermic needle or electron gun. The needle is attached to the high energy is dissolved in a volatile solvent, and it's attached to a terminal with high voltage. That's how you say it. Volatile solvent is used. Then after that, you have acceleration. So positively charged, that's cation. Cations accelerate it towards negative detection plates. There's an official AQA booklet for this. I'm pretty sure I have it behind me. Let me change the angle of this. Ooh, my phone. Boom, 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 boom. AQA, yeah. AQA mass spectrometry. They have a booklet somewhere. I'm sure of this. Oh, here it is. So what am I looking for? There we go. Acceleration, the equation we use is KE is equal to mv squared. No, half mv squared. Okay. Kinetic energy, mass, velocity. Therefore, velocity is equal to the square root of 2k E over m. Given all the particles have the same kinetic energy, the velocity depends on its mass. Yes. All particles have equal KE, therefore V depends on mass. That makes sense. Then there's detection. So acceleration, I need hand cream. 10265. Oh, thank God I didn't write that down. It's ion drift. Ion drift. Detected by a magnetic field into a curved path. So this is all in the flight tube. A hole in a negative charge plate into a tube. It depends on its mass. Yes. Time of flight. Wow, there's equations to learn. That's interesting. Ion drift. So I can label that in a second. All particles detected by magnetic field and time of flight. Okay, T is equal to D over V. T is equal to D N over 2K. Okay, we'll be given that if we're expected to use it. This is the drift. So okay, rise of atomic mass. Okay, sure. When using the electron impact ionization or electrospray, there may also be lower peaks due to fragments, but the highest one to the right. So the ones above it are isotopes. That makes sense. Okay. I'm so cold. But time of flight mass spectra. I need to do questions on that. Isotopes, time of flight. Can you explain mass spectrometry gives accurate information? Yes. Can you describe how mass spectrometry? Yes. Can you describe how? Yes. Can you interpret? Yes. Can you evaluate? Yes. Oh, it's quite short. Can you describe? Oh, Okay. Electronic configuration. SPDF. Okay. Can you describe electron configurations? I can't remember this that well. Let me get up the course guide on Kerboodle. It's physical chemistry. Oh, it's the first one. Oh, that's good. That's very good. Why am I so cold? I need to get a cardigan. I don't say too much. And a blanket and a cardigan because I'm cold. Okay. We have some tea. I don't want my tea to be too near my laptop. What was that? Calculation sheet, standard form, significant figures. WebQuest, isotopes, arrangement of electrons, particle, wave, cloud of charge. Ooh, write that down somewhere. Particle versus wave versus cloud of charge. Mass spectra. Got it. Oh, there's an animation. You know what? I should watch that animation. Okay. There are 4 sub-levels of electron. Those are sub-levels, like shells. Levels of shells. An electron fills a volume called an orbital. Orbital equals place where electron is. Atomic structure. An electron fills a volume place with an atomic orbital. Orbitals have different shapes and different energies. Okay, atomic orbitals fill up in a particular order, starting with those with the lowest energy. Orbitals with the same energy fill with a single electron before pairs are added. Fill one at a time. It's making sense now. It's all coming back to me. You can write the electron configuration. Okay. Electron organizations. Say the definition of ionization, but you haven't told me how many. Where's my textbook? This is biology. That's maths. Where's chemistry? Oh, it's been a while. We're almost halfway through this study session. That's good. Just over a third. She won't marry me. Okay, so number of orbitals. 1, 3, 5, 7. Okay, and each one can be filled by 2 electrons. So I want to sneeze. I really want to sneeze. My hair looks so bad. I actually look cute when I started. Okay. Am I going to sneeze again? What time is it over there? Right now it is 8:25 in the morning here in the UK. So there's S, P, D, F that has 1 orbital, 3 orbitals, 5 orbitals, 7 orbitals. So that can take 2 electrons, 6 electrons, 10 electrons, 14 electrons. But we don't look at F. We have S block, P block, D block. How could I forget? Oh, Ajilore, gorgeous little periodic table. I'm not the best artist. I need to learn how these fill up. Yep. Was that good English? That's the real question. This pencil's so blunt. Right, let's draw a really bad periodic table. know what? That's not the worst periodic table. It really isn't. Up to here. It's just a sketch anyway. And then F block is the length. Oh, that makes sense. That is the periodic table. This is F block. This is S block, D block, P block. And then we got a little S over here as well. S, S, D, P. That's my periodic table. What am I looking for? What does the spec say? Can you describe? Oh, yes. How do they fill up? 1S, 2S, 2P. Oh, so it does fill in a logical order at first. I knew I could remember some things. So the order is 1S, 2S, 2P, 3S, 3P, 4S, 3D, 4P, 5S, 4D, 5P. So the only ones that are in a weird order is 4S and 5S. So it's really not that strange. Okay, so 4S and 5S are a bit strange, but other than that, quite normal. There we go. Can you explain first ionization energy? Can you write equations? Can you explain trends? Okay. That's some good tea. All electrons, sublevels. State the definition, describe the trend. Ionization energy is the energy required to remove 1 mole of electrons from a mole of atoms in its gaseous state, and it's measured in. Let me put it in the bottom left corner. Ionization energy equals E required to remove 1 mole of electrons from 1 mole of atoms in gaseous state in kJ mole minus 1. Ionization energy is decreased down a group, okay, because there's increased shielding. Okay, so decrease down due to more shielding. Oh, because down the group you have the same number of electrons in the valence shell. Okay. Increases across a period. Increase across. Because there's similar shielding. Wait. Ionization energy increases across a period because the positive charge increases. Increase positive charge, but same shielding. See, this is very simple. Can you define the first ionization energy? Yes. Explain how trends in ionization energies prove evidence for the existence of electron energy levels and sublevels. The trends in ionization energies produce evidence because the drops in period in group 2, 3, and in group 5 and 6. My head. I have a headache. Okay. So let me get a different hairband because this is not working. Okay. Ooh, we're officially halfway through. Thank you for sticking here. I think I will be doing this every morning. I'll put it on my community tab every morning, studying together. Okay, explain how trends in ionization energy. The trend in ionization is so low because drops. Where's my periodic table? Group 1, Group 2, Group 3, Group 4, Group 5, Group 6. Okay, so here we have 2 versus 3, 5 versus 6. So, please make that make sense one more time. These drops correspond to the first electron being added to the p orbital and the first electron pair. First electron added to the 3p and the first electron added as a pair in the 3p orbital, both of which are easy to remove. Drop in ionization energy of group 2 to 3 and 5 to 6 equals evidence of sub-levels as first. Yo, don't spill. This is red tea. Evidence of sublevels as first electron added to SPD. That's the D block because that's trans. I know that for a fact. I'm not making that up. Okay, I'll leave that for a little bit. Let me even message. The following resources support this. What's the ionization? Oh, there's a podcast on this. I should probably listen to that as well. Summary. Okay, that was useful, kind of. Let me harass you. No, that's the wrong one. Oh, there she is. How is ionization energy? How is the ionization energy drop from group 2 to group 3? And will she still be revising? Because sis doesn't have exams anymore. Group 5 to group 6. How is the drop evidence of sublevels? Question mark. Let me Google that as well. How is drop of ionization and energy evidence for sub-levels? How? Tell me. Sorry about my chair making so much noise. Tell me why. Ouch. Nothing but a heartbreak. Tell me why. Niels Bohr. Do I need to think about Schrödinger? I don't really like him. Yeah, I don't really like him. I'm not going to write about him. I never want to hear you say my neck. Chlorine. I want it that way. Removing electrons one by one. I need to do the equation as well. Trends. Where is there a drop? There's a drop in aluminium and there's a drop in P and S somewhere. Somewhere between P and S. Okay. Oh, here it is. Period 3. There's a drop in Al. There's a drop in S. This is magnesium. This is this phosphorus and sulfur? This is phosphorus. This is sulfur. Okay. You still didn't answer my question. You did not answer my question. Okay. Is this period or is this group? Period. In period 3, Al and S have lower ionization energy because for S, let me just draw it out. These are my orbitals. It's easier to lose. And then Al, because and this is because 3p1 is slightly higher in energy, therefore, wait, magnesium drops when it should be up here. I need to check this again because it's not making sense. Heard you talk about we a lot. We speak French now. Why is aluminum ionization energy lower than magnesium? That ionization is lower than magnesium. The same person, aluminum. It's not making sense. I use the explanation to S orbitals penetrate better than P orbitals. However, orbitals, boom, boom, boom. One unpaired electron. Those two are paired. It's favorable for them to be paired. But then that's opposite to... Can you make this make sense, please? Because it's really not making sense. It's really not making sense. I might have to find a mark scheme for that because it's not making sense. Heard you talk about we a lot. We speak French now. That's the wrong one. It's this one. Can you explain period 3 and group 2? That was the issue then and it's the issue now because how do I put that to words? Other than that, let me actually draw up the equation and then this mind map is done and it only took 40 minutes to revise. Group 2, same pattern. It goes down. The nuclear charge increases, but there's more shielding. Okay, let me just draw some equations somewhere. Let me do it at the bottom of this section. Now, sodium gas goes to plus E. That's 496 kJ mole minus 1. Na plus gas goes to Na2 plus gas plus electron, which is equal to 4563 kJ mole. And one more for luck, Na2 plus gas goes to Na3 plus gas. Why is it a gas actually? I didn't even notice. Oh, because it's gaseous state. Okay. That was a silly question. -1. That is gorgeous. That's the equation. So other than the ionization energy stuff that I need to work on, I am done and I can do a bunch of exam questions on this topic. Wow, the revision has been done. Whoa, they all came out. Let's just use yellow for this. So that part isn't finished. And this part isn't finished. But everything else is finished. That's awesome. That's really awesome. This doesn't make any sense, but it will make sense at some point in the near future. So let's put the yellow. It should have been purple because it's chemistry. I realize it should have been purple because it's chemistry. So I don't know if you guys can see that. Ooh, it's going to be bad quality. I'm so sorry. I'll work out something for this. Ooh, I think I'm going to swap and put you guys on the other side because that might have better quality. But anyway, the mind map itself is complete. So I am going to do exam questions now. Is that amounts of subject? That's amounts of substance. So where's my atomic? Here it is. Here is my atomic mass exam question. This is for over here. Okay, let's swap places. This comes to this side and this comes to that side. The lighting is slightly better, I'll give you that. My lip gloss is down here. Lip gloss, lip balm. Okay, you guys are on this side now, and that's slightly better lighting. So I can live with that. You can see my timetable. Is it this way? That is, what is that? Saturn, the day the Earth smiled. I got that from when I went to NASA. I went to Griffith Park Observatory. If you have a list, that's very hard to say. But essentially, actually, my bunny is not bad. Wow. In La La Land, the big dome place with the telescope, that's where I went. So that was nice. Anyway, I'm going to do some exam questions. I've got a little booklet here. I have a couple from different teachers, but essentially it's just all the exam questions over the past few years put in here. So it's not in numerical order or anything. But I'll see if I can get a mark scheme up actually. Oh, I just saw it. There we go. A-level exams. Scroll down. What is this? This is atomic structure answers. Okay. I've got the answers here. And I've gotten my green pen ready to mark. I think this side is actually better. You can see my vanity in that. Let's do some revision guide questions as well. Then I can say this topic is well and truly revised. Okay. Why is it so cold? Define mass number. Mass number is equals to protons plus neutrons. So in this one, it's 7 protons, 7 electrons, and 8 of these. Is that it? How many marks is that? 3 marks. That was a very nice question. I doubt my papers will be that nice. Define the term relative atomic mass. An organic fertilizer was analyzed using a mass spectrometer. The spectrum showed that nitrogen in the fertilizer was made up of 95.12% fat and 4.88% N15. Calculate the relative atomic mass. Okay. Relative atomic mass is the average mass of an atom of an element compared to, yeah, that's what I say, compared to C12, which has mass of 12. Then the calculation is 95.12 times 14 plus 4.88 times 15 divided by 100 is equals to 14.0488. So 14.0536 fig. So that's 14 times 25. That is the maths. In a mass spectrometer, under the same conditions, the ions follow different paths. State the property of these ions. They have different mass. State one change in the operation of a mass spectrometer that will change the path of an ion. 47 parts. I've done quite well. That's actually quite good. So N15 is heavier than N14. State one change in the operation that will change the path. Electric field. I don't understand that one. So I can get 1 mark for that. The second mark, what does it say? The magnet. The magnet is something that I know and that makes sense to me. But the other things you're saying are not making any sense to me whatsoever. I actually really like this one. Wow. That's actually impressive considering that I didn't look at it. That's actually nice. Wow. Okay. I'm getting distracted. Organic fertilizers have a higher proportion of N15 atoms that are found. State why. There we go. State or explain whether or not you would expect the chemical reactions in nitrogen compounds to differ. Assume nitrogen compounds are the same. No difference. Because same number of electrons in outer shell, which is what determines the reaction. How many marks is that? 10 out of 15. No, 10 out of 11. 10 out of 15, that should be okay. 91%. That's not bad. Next section. Ionization energies, Mg plus. I need to get a periodic table up in front of me because 1s2, 2s2, 2p6, 3s1. 1 mark. First ionization energy is the energy needed to remove 1 mole of E from 1 mole of molecules in gaseous form. It's Mg, which is a gas, plus goes to Mg2 plus E minus. Is that correct? We got it. 1 mark. Explain why the second ionization energy is greater than the first ionization energy, because the electron is removed from positive ion, therefore closer to nucleus, so more energy is needed. Solid. Use your understanding of electron arrangement to complete 700, 1400, 10K. So make this one 8K? No, make it 6,000 because that's a guess. Anything between 5,000 and 9,000. Wow. My mind is too powerful. 1, 1. Okay. A mass spectrometer. Why is this not loading? Ooh, it's almost been 1 hour. Thank you to everyone who's joined. It's final 10 minutes. We can do this. We can get through this hour. Okay. Woke up the price of car. Define the term relative atomic mass. Have I done this already? Yes. Average mass of 1 mole of an atom compared to C12, which has mass 12. So I have to include that, which has mass 12. And that is, we're not doing German, that's the wrong spelling. Element X has a relative atomic mass of 47.9. Identify the block in the periodic table to which element X belongs and gives the electron configuration. Where's my periodic table? It belongs in D block. Woke up. Calculate the number of neutrons. Neutrons. Period. Yeah, use my periodic table. The mass spectrum. Use this to calculate the relative atomic mass of Z, giving your answer to 1 decimal place. Okay. It's all going to be over 100. Ooh. So it's going to be 90 times 9 plus 91 times 2 plus 92 times 3 plus 94 times 3, all over 100, which is equals to 91.2, and it's ZR, which is zirconium, 4 marks. Okay. Woke up the price of coke up. I just hit them with the low cut. State how vaporized atoms of Z are converted to Z plus ions in a mass spectrometer. State and explain how the ions formed will be detected. Okay. High energy electrons it's hit with high energy electrons from electron gun, which knocks, oh my gosh, I need to sneeze. It knocks out electrons and state and explain which will be the most deflected. 90 Z plus is most because it has the lowest MZ. This one, please make it make some sense. Explain briefly how the relative abundance of an ion is measured in a mass spectrometer. Ions hit detector, pick up E, and therefore cause charge flow. Bigger current equals higher abundance of that isotope. I'll give that one is 3, that one is 2, so that one is 14 out of 15. Woke up the price. That's 3%. That's not bad. Mass spectrometry can be used to identify isotopes in terms of fundamental neutrons. That is the difference, the number of neutrons. Could I say amount? I feel like I could say amount. I just hit it with the low and call my folks up. When buddies about to get poked up, I'll call the tow truck. Are they tucking out your neck? This state why isotopes have the same chemical properties. Properties. Same in shall therefore react the same. That is why this tea is so good. Okay, let's look at the mark scheme. That is not the question I just did. Oh, same electron consistency. Oh, well done. Oh, it's only one mark. Ew, why are you so stingy? Relative atomic mass is average mass of atom relative to C12, which has mass 12. What teacher did I do this with? Oh, I know. Okay. The mass spectrum of element X has 4 peaks. What's the calculation? It's 64 times 12 plus 66 times 8 plus 67 times 1 plus 68 times 6. Who's messaging me? Ooh, 4 minutes until the study with me is done. All over 100, which is equal to 65.6. Use a periodic table to identify it. This is zinc. 2 marks for saying it's zinc, and another mark for saying it's a positive charge. So that's one reason why particles with the same mass and velocity can be So that's one reason why particles with the same mass and velocity can be deflected by different amounts. Isn't it fragmenting? Size of the charge. Oh, I didn't get that one. Different charge size. So you can be the same mass and have the same speed. If you have a different charge size, you're going to take a different amount. Okay. Explain how the detector is used. The detector, so ions hit it, therefore cause current. Bigger current equals more abundant. Ooh, it's about 1 minute till the study with me is done. That's crazy. Let me just finish this exam question. How many questions do I have left? Oh, I have quite a few. I might stay for a little longer. Indium in group 3 is the periodic table. Those are the 2. Okay. Let me do the maths. 2 plus 2 plus 6 plus 2 plus 6 plus 2 plus 10 plus 6 is equals to 36. Then you double it. Sorry. Oh, no. You don't double it because that's the number of electrons inside that orbital. Use your understanding of the periodic table. That's a long electron configuration. Are you actually going to ask me to do that in the exam? Plus 10, plus 2, plus 1, 49. Okay. You guys are actually mean because why would you make me do that? That is a lot of maths. For how many marks? 1 mark. Of course. A sample of indium can be analyzed. State what is used to analyze an electron gun. Bing. Electron gun. Why is my throat hurting? Okay. Write an equation including state symbols for the ionization of indium. Okay, so indium is IN, right? IN, which is a gas, goes to IN plus, which is a gas, plus E minus. Only 2 marks. Oh my gosh, you guys are being stingy. State why more is not used because you'd have fragmentations. That's why. Oh, sorry. So You want to prevent further ionization. Give 2 reasons why it must be ionized. For detection, for acceleration. See, I'm actually, no, I'm only halfway through this. Ooh, 35 seconds. Can I try and finish this question at least? Let me try my best. Give the meaning of relative atomic mass. I've written this so many times. Average mass of an element relative to C12, which has mass 12. Use the data to calculate the ratio. Ooh. That's it. That's 1 hour of studying. Repeat, I'm actually doing 2 hours. But I think I'm going to leave this live now. Thank you so much to everyone who came here to study with me. I am going to put it like officially on my, what's it called? Community tab, 8 a.m. every morning. I'll be here. Probably not Friday mornings because I sleep until 6:30 on a Friday. But yes, I will be here. Thank you so much for watching. Smile, subscribe, study hard, slay hard, and I will see you guys very soon. And one day I will work out how to stop this stream. But until then, bye.